So this is the video recording to go with lesson 6.1. These are some of the questions that have been assigned. So starting with 8C, these are slightly more tricky questions when we're actually asked to find tangents, normals, maximums and minimums. So something beyond basic, just differentiation and possibly substitution in of a number. So we're given the equation y equals secant x here, and we're given this x value here, and we're asked to find a normal. So we should recognize this as a question where we're trying to find the equation of a line. So we should be thinking about point and slope. And for our point, we've only been given half the point. We've just been given the x value. So to find the y value, use the formula. So plug in for x, which is pi over 4, and then you can work out secant of pi over 4. Of course, if you don't have, obviously your calculator doesn't have a secant button, you could also put 1 divided by cosine of pi over 4. And if you've got that good Casio calculator, it should tell you straight away that it's radical 2. Otherwise, you're going to have to work it out by hand, because it'll give you a decimal. Now, to find the slope, that's why we're going to be differentiating this. So the differential for secant is secant tan of the same thing. So in other words, x and x. And to find that slope, we have to do the same thing again. We have to substitute in for x, which we know is pi over 4. And once again, we've already actually worked out secant of pi over 4. It's up here, radical 2. So radical 2 times tan pi over 4. And tan of pi over 4 is just 1. So we're getting radical 2. What I should emphasize at this point as well is, as we're plugging in something that's in radians here, we need to make sure our calculator is in radian mode, or else we will get the wrong answer. Now, this, though, is the slope of the tangent when we just differentiate, and our question says the normal. So we're going to need to do the negative reciprocal for this as well. So that would be negative radical 2 over 2. And remember, if you use your calculator for this, it will actually rationalize for you. So negative 1 over radical 2 should give you negative radical 2 over 2. Now, I summarize the information that we have. We have our slope for the normal, we have our x-coordinate, and we have our y-coordinate. And then from here, we can just go ahead and use our point slope formula. And to be honest, that should be the part of the question that's not actually too tricky. The first part of the question really is the important part, the one with the trig differentials, and working with those numbers. Now for question 9, this is where we actually have to start finding maxims and minimums. And you might not specifically be asked to find this question depending on which year you're in. But we'll go through the process, because I know certainly 9C you will have to do. So for this question here, if we're going to find maximums and minimums, we need to find slopes. We need to find when the slope is 0. So to do that, we differentiate. So differential of sine is cosine, and the differential of cosine is negative sine. We're also going to need to show if it is a maximum or a minimum. So we might as well go ahead and differentiate for a second time right at the start. So the differential of cosine is negative sine. And the differential of sine is cosine, so as it's negative sine, this will just be negative cosine. So first step then, to find maximum minimums, we set the first derivative equal to 0. And I would always write that down as well. Show the examiner you know what you're trying to do here. Just do that little step of explanation. So it's basically when this equals 0. And the key step from this one, from Unit 5, is as we're trying to solve this, what we're really trying to do is just make a single ratio. So if we bring the negative sine x to the other side, once it equals 0, it'll become positive sine x. Probably would have been better here if I'd have written cosine x equals sine x, because that's really what I did at this step. And then from here, if we divide both sides by cosine x, sine over cosine becomes tan, and cosine divided by cosine just becomes 1. And then we can solve this. Now, it depends how you feel more comfortable. In theory, you're supposed to be working in radians for this question, unless it specifies otherwise. Sometimes people prefer to do it in degrees, and then at the end of the question, they'll change it back. So I've got them in degrees here, but I have put the radians alongside just so you can see what they are. So we know that there are 2 stationary points or turning points. What we don't know, though, is are these maximums or minimums? So as we're doing this, if we did do this in degrees, when we substitute into this second derivative, we do need to make sure that we change it back into radians at this point. So if you plug pi over 4 into here, what you should notice on the calculator is that it turns out to be less than 0. Remember, that's what we're really interested in. Is this less than 0 or is it greater than 0? And if you plug 5 pi over 4, you get about 1.41, which is greater than 0. So if it's less than 0, remember that means it's a maximum. If it's greater than 0, it means it's a minimum. If it equals 0, then you have to do that first derivative check. Now, we don't specifically need to do it for this question here, but I am going to check just to see what actually happens. So, as we know that it's 225 degrees, if I check just slightly to the left, as in 224 degrees, I would notice that I get a negative value for here. Oops. Now, I just noticed that that's slightly incorrect there, so I'm going to be very careful about this. So I'm going to scroll back up here. If I'm doing the first derivative test, and that's why I noticed there was a mistake here because I was using the second derivative. If we take a number slightly smaller than pi over 4 and substitute it into here, and then choose a value that's slightly bigger than pi over 4 and substitute it into here, then we can actually look to see what happens. Now, I'm going to show you the picture, but we're going to ignore the writing because this part's wrong. So if to the left, let's supposing the first derivative was negative, then we draw a little negative slope. If we find the second derivative is positive, and then you kind of have to complete the dots a little bit to figure out what it is. So this would look like your minimum, and then you can make that decision. Similarly, if just to the right it was positive, sorry, just to the left it was positive, and just to the right it was negative, then you can kind of see this is going to look like your maximum. And actually, if you get the same answer for both sides, as in both positive or both negative, then you could actually put point of inflection. Once again, remember this is actually slightly incorrect. This is supposed to be the first derivative. And also, when we're plugging in here, we should really be plugging in radians. This was just to show you it was slightly smaller than this value here. It's not so easy to think of a number slightly smaller than pi over 4. That was why I changed this into degrees just for a second. Now, for question 9c, which is more difficult than 9a, we have to differentiate again. And also to differentiate this, we're going to be using our chain rule as well. So to do the chain rule, remember this means sine of x all squared. So you'd bring the power to the front, 2, sine x to the power of 1, because we decrease the power by 1, times by the differential of what's inside parentheses, which is sine x. So the differential of sine x is cosine x. And here the differential of cosine x is negative sine x, so we'd have negative 2 sine x. Now, we could probably try and solve this, but when we're trying to find a second derivative in a second, we're going to have a problem here, because we actually have a product here, and we don't actually cover how to how to differentiate products of functions until the very next unit. So why would they put that in this unit? Well, as always, you should be looking for identities on this question, and that's actually the identity for sine 2x. So as you're doing questions, try and keep that formula sheet in front of you as well, and if you hit a problem like this, just look to see if there's an identity that you can use instead. And that's still dy by dx because I just simplified at this point. Now I can differentiate though. So differential of sine is cosine of the same thing. Differential of 2x is 2. Differential of sine x is cosine x, so I keep the negative 2 at the start. So that first step, of course, differentiate, set it equal to 0. So I'm actually going to go back to this one though. And the reason I'm going back to this one is these are all in terms of x, where this one's in terms of 2x. So this one and x. So this one's going to be more useful to try and solve. But I needed this to be able to do the second differential though. So let's go ahead and differentiate that first expression. So I want to know when, this first differential equals 0. And notice we're looking for GCFs here, so I can see sine x as a common factor. I can actually see 2 as a common factor as well. And then once I factored as it's equal to 0, either the first thing equals 0 or the second thing equals 0. So 2 sine x equals 0 would be sine x equals 0. And you can actually just look at the graph for that one. You should find it's at 0, 180, and 360. In the question, I think it says we don't include 360, but we're going to eliminate that in a second. Cosine x minus 1 is 0. Bring the 1 to the other side. Cosine x equals 1. And if you look at the picture, it's 0 and 360. So notice these two are actually repeat values, so they don't actually add anything. So all our answers are actually contained within here. And as it says 360 is not included in the question, that means our only two answers then are these. So we have to look carefully at those inequalities. And remember, this is also going to be 0, and this is really going to be pi if we're doing these questions in radians. So if you want happy doing it in radians all along, you can certainly do that, but I know some people do not like using radians at all. For our second derivative, to find out if this is a maximum or a minimum now, we can go ahead and plug into that second derivative. So 0 is obviously still 0. And this time, actually notice the second derivative does come out at 0. So when that happens, we've got to go back and do that first derivative check that we did in the last question, just to check what actually happens here. So I chose something slightly smaller than 0 radians. So I went with negative 0.01 just to see what actually happens. And I get a number that's slightly bigger than 0. I don't really care what the number is. I'm just interested, is it greater than or less than 0? Pick a number slightly to the right of 0. So I went with 0.01. Work out what that gives you. And you get a small negative number, but it's certainly something that's less than 0. So my first answer is positive. My second answer is negative. So as I go back to the point, and once again, this is actually supposed to say dy by dx. dy by dx. Oops, let me get rid of that point there. Then what we would notice is we'd have positive slope to the left, negative slope to the right, and as we join those up, that would actually give us our maximum. So that's one way we can check. For the other value, it actually worked fine. If you plugged in pi, you got an answer of 4, which is clearly greater than 0. Therefore, we note that it's a minimum. So hopefully we won't get anything like this, because it's that little bit more complicated and there's those extra steps to do. But certainly worth reminding you about the first derivative test for when we get 0 as the answer to the second derivative test. That doesn't confirm if it's a maximum or a minimum, and then we have to do that little check just to see. That should conclude the video for this section. Those were 2 of the questions certainly that you would have appeared in the lesson, and there's an extra one in there that you might not have seen this year as well.